Sweet.
Cool. Thanks, Marty. So I started recording. Hey, folks, thank you for joining me. We have a busy agenda for today, allocating a couple hours for that. So again, thank you for joining. The regular stuff, we'll start with what we do and obviously always asking for volunteers to have some talks in my in our meetup. So this is our 32 one. This is November 16. I'm going to mention that Qualcomm WRD Software is from San Diego is sponsoring that, paying our meetup fee. So thank you for that. Cool. So this is recorded and we're going to be uploaded to YouTube once we're done, hopefully today. And also Martin, I think we also linking that from your blog.
Yeah, that's right.
So, good. So
once the video is up, I'll link to it.
Sure, thanks. So what do we do if you are new? By the way, anyone new here? So Leila, you're one of them. Anyone new? You can raise your hand. Just curious to see if there is anything. Anyone that I know a lot of. Hey, I see 2-3 people. Welcome. Thank you for joining. Let me tell you what we do here. The idea here is to get together once a month, and we started that almost three years ago. And the idea is just to promote C++. It is San Diego C++ Meetup, but it started with a real meetup, people actually meeting face to face. But when the whole pandemic started, we started going virtual, and then it actually opened the opportunity for other people. I back then when we met face to face, I didn't do any recording, and it was a small group, about 12 people, 12 to 15 people meeting in office, and we didn't have any recording. The idea is to promote C++ San Diego or beyond San Diego. By the way, San Diego was voted for the #1 city, fun city I think in US. So that's good for us. So we want to promote that. We want to promote C++. There's tons of resources. There's tons. I don't think we would ever run out of topics. We have mixture of beginners, intermediate, maybe a bit more the expert. I'm trying not to be on the super expert part because most of us are not experts. There's a very kind of a handful of people that are really, really experts. So we're not going into the crazy meta programming and all. But you are welcome if you want to have a talk about a more advanced feature. I'll be more than happy to host you and learn from you. And we all learn from each other. So the idea is, although I'm bringing the agenda, you can participate and first of all ask questions and have discussions. When you say ask questions, there are people on the bridge that can answer, not only myself. Plus, we are here just to share ideas and just learn something new. That's I think that's the main thing that I want to achieve every time. And I learn every time I host it, I learn something new. So there are multiple resources. I'm just listing few of them here, but just just tiny few bullets. Martin has a great blog with tons of things that I think each of them can be at least one talk. So that's something that I think long time ago, start following Martin, I had the idea that I'm gonna have a talk from each page. That was the idea. So so that's one thing that you can think about. And I think I shared that in the chat. So if you have access to the chat, apparently not everyone has this access, but if you do have access to the chat, and the link is there, and I also posted that in the meetup.com, and I'll put it in the header of the meetup.com so you can actually have that accessible. So what do we do today? We'll have C++ quiz. We actually have all kinds of fun, crazy things that we can learn. I'm going to talk about remove and remove if. So what does it does? What does it do? And there's all kinds of misconception about what remove or remove if. What does it do? So we'll go over that. A couple of Stack Overflow. One of them is something that might be obvious, but definitely something that I want to mention. The second one is actually something that I learned. I didn't know a specific nice utility in C++ 20, I think. We'll see it when we get to it. Array references and pointers, something very basic that comes from C, kind of a recap about that. And then we'll talk about large-scale C++ book, volume 1, and I'll have a shout out for 2 new books that are coming out very soon, so you can pre-order them. Some WalletFox from WalletFox website slides that I want to go over, and there is a talk from me about my quest for a QuickSort. That I mentioned that long time ago that I had some some exercise that I started and went into all kinds of interesting things that I discovered. And Jason Turner, in one of his, he has a few channels in his Discord space, and I'm a Patreon of his page, and I have access, and I asked him, okay, Jason, what do you think about this? And he helped me to kind of nail the last bit. So very interesting thing that I learned, and he actually really liked this exercise, and he said that he's gonna create few weekly C++ episodes from it, and yeah, he asked for permission. I said, yeah, go for it. Okay, again, sponsored by Qualcomm WRD Software. Thank you for sponsoring that. We have a Dropbox that I upload the slides. We have a Slack channel that I'm barely there. We have a Discord, also barely there. But feel free to use it if you want to chat with other people in the group. SDCPP Meetup. This is our YouTube channel that I'm uploading our recording, and I definitely need to add here the link from Martin because we're uploading there as well. I have a handle SDCPP Meetup that you can subscribe. It's very light tweeting from there. It's just the announcements and things like that. My Twitter handle is Kobe_CA. That I manage both accounts, obviously. Okay, without further ado, let's start with our first thing. I'm going to do is I'm going to stop here, and I'm going to share it's just easier to share the actual website. Okay. So the first one is question 3. Okay, you can see it, right? So this is CPP quiz. They have a GitHub that hosts everything there, and I find it very educational to go over that. Some of them are pretty tricky. Some of them are pretty obvious and fundamental to the language. So it's a mixture, and it's all C++ 17 right now, as far as I remember. They might start adding 20 soon, I think. There are 3 difficulties, and the first one is difficulty first, like the easiest one. So we have 2 functions that are overloaded by either signed or unsigned. And the idea is if we pass a double, so this is double. what would be the result. So it can output something, then we need to put something, for example, 1 or 2, and then answer, or compilation error, unspecified, or implementation defined, or undefined behavior. And the idea here is that you participate, and it's fine to get it wrong because there are all kinds of dark corners of the language that we don't have to get it right, but it's good to, go over it and maybe remember that for the next time. So what do you think would happen here? This is where you shout the answers.
All right, I'm gonna guess. I'm gonna print 1.
1. Why?
Because of this being an unsigned, and it would be 2 conversions. So minus 2.5 would need to be converted to like a -2, and then to unsigned. I don't know if this is exactly like the user-defined conversions, but I think the hop between -2.1 to int is a shorter hop.
So
But
the question,
again,
yeah. So the question
guessing.
is, and I don't remember what I was guessing when I was trying it. And I prepared the slides, by the way. Usually I don't. It takes me some time, but I prepared all the slides on October, like mid-October. So I don't remember what I was picking back then. So, but I know the answer. And the question here is, there is a conversion, right? If the compiler needs to call one of the overloads, it needs to convert either to int or unsigned. So the question is, what conversion is better, right? If 2.5 or minus 2.5 in this case has a better conversion to integer, then it would go integer. If it's unsigned, it's unsigned. In long story short, what I remember, it's compilation error. I think they are equally, the conversion is equally. Let's say if I remember that. Okay, so the nice thing about the C++ quiz is it gives you the answer. So it does give you the quote from the standard, but the idea, it has like a kind of a more human readable answer. And here in order to select one of them needs to be better than other, or it's ill-formed. In our case, they equally good, and then it is ill-formed. All quadratic are given a rank, so both of them are double to int and double to unsigned are type of floating in integral conversions, which has rank conversion and so on and so forth. But the bottom line is that it's equally it's kind of equally the same, equally good. Okay, let's go to the next one. So the next one is 38. This is actually
Is the floor open?
yeah, the floor is always open.
Okay. So I think B is a reference to A because of the decal type with double parentheses.
Okay.
I think there's different rules for determining the type.
This is fun rule. So what would be, so both of them are 1.
Yes, that's correct.
Yeah.
I think
this is the answer. Okay. So Martin, you said something which is, I don't know how you remember that, but when I sometime back got into this use case, bumpy to this use case. I needed to kind of memorize the rules. I don't know if I'm just curious. Anyone else here knows about this rule? It's kind of a funky rule, and to make things. So what I did, give me a sec. What I did, I prepared you something to confuse you even more. So just like Martin said, this is because of the double paren. It's actually a reference. Okay, so you see this C++ insight, right? So I have this x. It's just an integer. I'm initializing to 0. Doesn't matter. So I have auto, and I'm returning x. I have auto, I'm returning x with paren. I have decal type auto with x, and I have decal type auto. I'm returning x, but with a paren. Okay, so what do you think would be this one? What is auto? The question is what is the return type? So this is an integer.
Yep.
This is also an integer. By the way, this is what I remember. What
Yes.
about this one?
Also an integer.
And what about this one?
This will be a reference to int. You need decal type and the return statement.
Yeah.
That's like the only exception language where actually extra parentheses in the return statement make a difference.
Exactly. And what in my code base at work, at least, I don't see decal type auto as a return value. I think the first time I was reading it in a book, was the book that Scott Myers wrote on the modern C++, the modern C++ book on Scott Myers, like his last book before he retired from C++. And there is a decal type auto. I don't know if it was I can't remember if it was a chapter or it was just part of a chapter, but there is description of the rules there. And what I suggest people is not to write return with paren, although it doesn't really matter, but there is one case that it is matter, and someone in the future would do this decal auto from either auto, maybe, and from an integer, it becomes a reference to an integer, and things would behave differently. So first of all, my opinion might be wrong, is don't use paren unless you know what you're doing with this paren, and especially with the combination of decal type auto. So it's a very kind of a salty, I don't know, what was it's difficulty kind of a medium, but I would say it's a medium. It's between well done to medium, in my opinion. I'm kidding. So medium plus. So so that's 38. Yeah, I'm just a messenger here. The language is difficult. 113. Also medium. Okay, so according to the C++ standard, what is the output of this program? Okay, so we have a template. A function template. By the way, this using namespace stud is just a convenient. Don't use it in your code, please. My opinion, people's opinion, don't use it in your code. But this is just an example. So just instead of using stud cout, there is a primary function template here, and there are two other functions. One is a specialization of this primary template, and this specialization is for an integer. So t is an integer, and there is also an overload for an integer. Now, this is a good opportunity for me to first, I don't have the link, but there is a great link from Herb Satter, I think before 2010. I think it's a very old link, but still applicable, still good, about exactly function templates, overloading versus specialization, when to do it, when not to do it. The bottom line is don't specialize, overload if you can, because what happened is overloads are better than specialization. They are kind of first class versus these are kind of second class. But I'll give you the link later. I'll need to kind of Google for it. It will take me a few seconds, but I'll Google for it and I'll send it. But worth looking at it. Let's go back to this specific question. So we have F with 0, 0, F with 0, and F with another 0. So this is double. This is just an integer, and this is the specialization part. Okay, so what do you think about this one? It's 1, 2, or 3?
I think it's 1.
It's 1. And it's pretty simple. We have a template, and this is perfect for instantiation for double. We don't have anything else, so it's gonna instantiate it. And then we have F of 0. What happens here?
3.
Someone said 3. Why? Why 3? I think 3 is the correct one. If I remember correctly. Sorry? I can hear you cutting.
I think if compiler has to make a decision between function and a function template, the functions have higher priority.
Yeah, so here's the thing. Yeah, so think about this guy as a nested. Like if you think about, I need to pick something. The compiler first, this is a nested inside this one, nested in logically speaking. Okay, so the compiler first take a look at these two. If there is a match of any of them, and there is a match here, overload would be picked here over template. It would stop here. Even though there is an integer here, the compiler doesn't even look at it. And again, I'm gonna refer you to the Herb Sutter article. It's a great article that explained that. So I think it's also gonna be 3. And then we have this. What do you think about this?
I think it's 2.
Has to be 2 because it's a template.
Yeah, we're explicitly calling the template.
Yeah, it's a template. This is out of the picture. It's out of the question. Like there is no because this is F. I'm saying I want the template function. Find me one. So it goes here, and now it looks at the nested one. This is a nested of the primary. And so, oh, I have actually specialized for int, and let's see if we got it right. I think this 132 is the right one, but let's see. Okay, it's correct. Basically, what I just said is here. It's pretty long. So again, everything would be uploaded, so you can go and take a look. I want to move forward to the next thing. Otherwise, we want to have time. So let's go back. Okay, do you see it? So we're gonna skip the other ones. We'll do it next time. Okay, what does remove, std remove or remove if? What does it do? So here's the details from CPP reference. So there are multiple kind of misconception about what it can or what it would do. One of the misconception is that it's actually shuffling stuff and preserving the one that are removed. They are somewhere at the tail of your container. Let's talk about vector just for an example. So the question, does it make or copy the removed ones to the end? Does it keep the order of the original container intact, or would it be shuffled like at the end result? Does
Yeah,
it
I think so.
It
preserves
does, yeah.
the order.
It preserves
it
the order.
actually-
Yeah, and it says here somewhere. I don't know if here or later. Does it shuffle elements in the container? So the idea behind remove if, it doesn't actually remove anything. What it does, basically, it would give you a pointer to the element past so basically you would have range from begin to a pointer that is returned from remove or remove if. Remove if is just a predicate that is a lambda versus remove, which it's basically a t, which is a value that can be compared to the to elements in the container, and it gives you a pointer to the element past the one that is that wasn't removed. Now it doesn't erase anything, but it does put everything that is not to be removed. So the predicate that didn't work for them. It's kind of shifting them to the top of the container, and then it gives you the pointer to one past the end of one. It's always one. Remember, this is STL end is always the one past the end, past the last one. So basically, you have now you have a range, and there is this erase remove idiom when you can actually now go and say I want to erase the elements from here all the way to the end of the container. So that's another thing. So if you take a look at an example, so let's say I have a vector of integers, just a very simple example, and I populate it from 0 all the way to 9, and I print it. Okay, now what I do is I write remove if it's even. Okay, so this is a predicate, and I print that. What would happen? So this is the original vector 0 to 9, and this is the result. So we see all the odds one here, and you'll get a pointer to this. Let me see. Pointer option. You get a pointer to. So this is 1 to 9. 9 is the last one. You get one past the last one. So you can see that some of them are, like for example, there is no 2. So it's not like it takes 2 and put it somewhere at the end towards the tail. No, 2 is gone. There is no such thing. 9 was kind of pushed all the way here, but it's kind of, there is 2 9s. So I wanted you to be aware that this is the GCC implementation. Obviously, other implementation might have different results, but I just want you to be aware of how your vector might look like. This is just integers, so there is no like side effect. But if you have object that the destructor is doing something and all, be aware that this is something that can be, you can observe all kinds of stuff related to this behavior. So be aware of that. I just find it very interesting to kind of mention that. And the order is preserved, as mentioned by Martin. Okay, so I found this Stack Overflow interesting. And the idea was I have 2 functions. One is computing Fibonacci in a compile time using constexpr, and one is compiling it without compile time intrinsics, like no constexpr, but just regular runtime stuff. And how does it do it? And the idea here is, I don't know if some people are aware of that, but the idea here is that there is something called memoization. I don't know if I pronounce it correctly. And the first time I actually got familiar with this terminology was actually in school, when I was actually learning from this book, first year in school, and there was a very similar picture. There is a very similar picture. I still have the book, by the way. It's a great book. And by the way, Quora Orchestra has, I think he still has sessions, a meetup just about this book. It's a great book, by the way, but very, very, very kind of very heavy at some points. So can you see my marker when I change it? Yeah. Yes.
Yeah, I can see it.
Yeah. Okay.
All right.
So basically, the compiler doesn't recompute stuff that's already computed. So A3 would not be recomputing all the sub-leaves that were computed. So there is, think about it like a cached table that is already populated, and the compiler is not like recompiling. Even if it's recursive, it's not gonna recompile it. And this is why it's done super fast. And again, I found it very interesting. The concept, I learned about it in '97 when I was actually first year in learning from this book, that I still want to go over after so many years, go over and learn it again. I need to go back to Connor Orchestra and do that. Okay, the next one that I wanted to share with you was something that I wasn't actually aware that there is such a nice utility about finding if a specific number, for example, int 32, can it fit into int 8 or int 16? Anyone familiar with the C++20 utility? It's kind of an esoteric, but I find it very, very useful now that I know about it. So this is one way that people kind of posted, and this is actually, I think, working. Though the question says that it's not working, but I think it is working. But the question was like, is there any better way to do it? And apparently there is this stood in range, which is a very nice utility that it's a template that you pass the type that you want to see if one thing fits into that. So would -1, which is an integer, it's a 32-bit integer on most of the machines, would it fit into int 8? So in range is something that you can use, which is I found it very, very useful to know. I don't know how many of you knew about this new utility, but the idea behind the new standard is there are multiple small stuff that were added, 17, 20, even 14 and 11. And it's really useful to know all of these small utilities because it can help with all kinds of. There's also a lot of bitwise stuff that were added to C++20, which I really like. There is an Endian helper utilities that were added. So lots of good stuff that I suggest you take a look at. Okay, there is something that comes from C that I found it very, very kind of useful to mention. So when you see these two function declaration, there is no definition here, it's just declaration. It's basically this int param 10 is basically the same as int point param. And the reason for that is that when you pass, if you have an array, when you pass it to a function foo, either this declaration, this signature or the other, they're basically the same. Arrays would decay into pointers. So they look the same. Now in C++, so while in C you have this, okay, I need to pass a pointer to the array and the size. In C++, there are multiple ways. This is the one way, but there's also span that you can pass, which comes with C++20. So this trick is very famous trick. If you have an array, like a real array, that you can pass it into a template function that has a non-type and an integral template parameter, and you basically can pass it by, this is by reference, and it deduced, and you can just send this array, and they're going to be, in this example, going to be 2 copies of this array. Let's say they're not inlined, but there are 2 copies of this array. One would be with n equal 20, one would be with n equal 100. So this is a nice trick that is kind of much safer than the C++ one. Let's go to our C++ book of the month. This is Large Scale C++ Volume 1. And by saying large scale, this is a very, very thick book. I think it's 1,020 pages, if I'm not mistaken. 1,024. Very nice number, by the way. Probably not picked by accident. From Jane Lakos, he's basically a speaker and I think a committee member at either currently or maybe in the past, I can remember. And he started, so this is volume 1. He has 3, so planned 2 more. So three volumes. It's kind of a series of books that he planned to publish. It's on Pearson, informit publication, what used to be Edison Wesley. There's like 3 publications in one, kind of merged. And it's a very useful book for beginners and up. It talks about, so I have some of the stuff here. It takes you through all kinds of design steps, assembly of modules, interaction between components, compilation strategies, compilation, linking components, packaging, namespacing, partitioning the namespacing. All of that is explained in great details in this book. You need a lot of patience. It's a really, really big, thick book. But it goes from the basic stuff all the way to the more complex. There's a lot of diagrams to kind of complement the whole thing. I was listening to his podcast, CPP Cast, that was published on February 6, 2020. And he was talking about his plan about volume 2 and volume 3 that coming in the next few years, that he would talk about interfaces, contracts, optimizations, unit testing. So everything else that he didn't cover in his current thick book. So this is his bio from CPP Cast page. So shout out to 2 books that I have a feeling that they would be very useful. So the right-hand side, both of them from the same publication, by the way. One, so the right-hand side is from Kate Gregory, which she's also a speaker in conferences. She's also she's having online classes. And Guy, I think Davidson, that some of you might know him. He worked a lot on the graphic technical specification. Sorry. So this is just came out, published on December, I can see here, 23rd. So just before Christmas. So looks something that worth observing and maybe pre-ordering. I actually pre-ordered that just to, out of curiosity. I want to see. I really like Gregory. What she teach, I pretty much align to it. And Guy is definitely a very knowledgeable person. The other one, again, John Lakos, the same guy from the other book, and also a few other people. At least one of them I know, Vittorio, which he is also one of the committee members, and he has also classes, and I also suggest following him on Twitter. He's a very brilliant person to kind of look at his work, and he's doing a lot of nice things. Actually, he had, if you look at his tweets recently, he's teaching C++ as well, and he created this nice utility that you take, let's say, a struct, and the utility prints the struct layout with the padding and all. Very, very useful. I really like this kind of things that, and I mentioned his work before. So this is a new book that would be actually on the same day, December 23rd. Good. So you can pre-order this as well. I actually pre-ordered both of them. I just want to support the creators. So just have a look at that. Both of them are in Inform IT. It looks pretty useful. just by looking at the table of content. Okay, so let's talk about 3 slides from Wallet Fox. And the first one talks about string view. So string view is pretty nice, very efficient. It's a pointer and a length, non-owning reference. If you're coming from Rust, usually you don't come from Rust to C++, it may be the other way around. But if you know Rust, I see string view, just like I see span, as a slice. So if you're coming from Rust, think about string view as a slice. Like internally, it looks probably the same. So it's a pointer and a length. So you can see if you have a specific memory region, in this case string, a pointer to one location and a length would be a slice or a view of partial. String view doesn't necessarily have a null terminated view. It depends what it's viewing at. So it might look at the middle of the string, so it's not null terminated. So people kind of, I keep hearing this misconception. Oh, string view is very confusing. You can't use it. It's not terminated. It's not null terminated because it doesn't, by design, it's not like creating a new string, a new null terminated string out of another string. It's just a view. It's just a pointer and a length. So what we have here is a string view as a parameter. And then we have s.substring, which gives you another string view. Okay. Now you have, so this is one option, and you have another option where you have a string and you have s.substring, and it gives you back a string view. Basically, it gives you a view, a pointer, and a length to some region in memory. So let's see what happens. So you have a string 0_AB, and you have fs. So fs would be this. So substring 2 gives you A and B. Okay, so from location 2 all the way to the end gives you A, B. So the idea here is that S continues to live from the moment you are here all the way to the end. How about when you send it to string? So we take it by reference, by const reference. And then we have s.substring 2. Now, the problem is you actually produce, substring produce as a string, right? So this is a temporary that would die when we are done. And then string view has a pointer and a length of something that died. And this is something that you don't really want. Here we didn't have that. The origin was string view. Substring would give you it's a slice of a slice. So everything is good. Here, s.substring will give you a new string. And then you have a view to something that is a temporary that would die. So be careful when you deal with string view. Be careful. It's not Rust that tells you, hey, you're kind of violating lifetime. You need to understand the lifetime here. So be aware of that. String view is a source of lifetime issues in many code bases. So be aware of that. Okay, special members. So what happens when you delete a copy constructor? So let's take a look here. We have a class A. We have so when we delete or we default here, we need to, if we want to bring in the default constructor, we need to have equal default. We do it here as well. So we wanted to delete the copy, but default the move, right? The idea here is that if we delete here on this left-hand side, if we delete the copy constructor, the move constructor is implicitly deleted. So in this case, in place back, which relies on move, compiles because A is movable, because we bring in the movable constructor, but here it's not compiled. People don't understand. I see a lot of code, maybe it's fine. People want to have the code non-copyable and non-movable. So you can do two things. You can have equal delete for the copy constructor and the copy assignment. By the way, if you do that, you are done. The class is not movable because it's implicitly deleted. But some people, they don't know it, they want to be on the safe side. They also do equal delete for the move, the copy the move constructor and the move assign operation. It's redundant. It's not a problem. It's not going to create a problem, but it is redundant. Okay. And I always like to look at this specific table. If you touch, and this is touching, equal delete is touching. It's like defining. If you declare a copy constructor and equal delete considered to be that, obviously the default constructor is not there. This is why equal default needed here, but also the move are gone. So this is what you created, user declared, and equal delete means that the copy is defaulted. You don't really have to touch it. It's default. You can, if you want to be more expressive, but these two are gone. So this is something that you need to be aware. Just I have a link for this table, but you can also, if you just Google special members and go to the images, just Google that, go to the images, you'll see this image. Okay, last slide before we go into the main course. This is L value expression in C++. It's something very basic, but always good to know. So string literal, for example, constar or hello are L value expression. You can take the address of this expression. So you can basically, if you have hello, there is an address to hello, and you can take the address of it. But some literals, for example, 42, true, null pointer, they are pure R values. PR value, pure R values expression. There is no way you can take their address. There is no address of it's meaningful. So be aware of that there is this distinction between these different literals, and only literals with which are L value can be taken the address of. Okay. So there is R value, there's PR values. This is a PR value, this 42. So you cannot take the address of. This is it for the 32 meeting marker. And what I'm going to do is, give me a sec. I'm going to swap to the next one. Okay, so share this one. Okay, so folks, so this is basically something that I worked on around April. Just I wanted to do an exercise, and the exercise was, can I? And I remember what triggered this exercise, and the exercise was someone from some blog or Quora or something like that was asking about QuickSort, and that actually triggered my idea that I would take QuickSort from C implementations on some website, and I decided to take the one from Geeks for Geeks, which is a website that has all kinds of algorithms and all. And they have all kinds of implementation. They have Python, they have C, they have C++. And I said, okay, can I basically take this implementation from Geeks for Geeks and either make it look better with modern C++ and hopefully make it runtime, make it on par, or maybe I would even make it better. But I didn't have this wild expectation that I can make it better, because it was really bare bones C, like a kind of bare metal C. There was like it's very hard to, I'll show you the code. It's very hard to kind of optimize this specific function. But I wanted to do something. I wanted to say, okay, can I modernize it and still be on par? And this would be a big win. And they had also a C++, actually their C implementation is actually a C implementation. They say C++ 14, but it's all C. I'll show you the code. You'll see that. And so I started my detective work trying to do that. I didn't realize it's gonna take me into all kinds of directions and a lot of frustration, by the way. Again, special thank to Jason Turner. He cracked the last, but the important bit. So again, thank you, Jason, for helping on that. One thing that one disclaimer, you'll start seeing the whole benchmarking and all. Your mileage might vary. Different compiler, different CPU, different flags, different weather. All of that can change things. And I'll mention that at least once. At least that. Looking at my experiments, you can go and have more. You can go back and try at home all kinds of other experiments and other compiler flags and so on and so forth, and see how it behaves. I actually encourage you to go and do that. You can have more insights other than what I have. I think there is more room for investigation. There are some kind of question marks that I don't address here in the talk, but definitely we can use Discord to use this work to kind of continue and ask questions and answer. So since April, where I actually started this whole thing, and actually I finalized the whole thing, I think in June, July, and it was on my to-do list to present it in one of the upcoming meetups, and November was the first opportunity. Since April, there are new compilers, so I didn't try the newer compilers. So you'll see that I'm using, I think, GCC 11, if I'm not mistaken, and Clang 10, if I'm not mistaken. Oh, I can't remember, but we'll see it. Some results would fluctuate. It'll be like a gain to this code or a gain to this code. It's like gonna fluctuate a bit, which is fine. I'll mention that. But the final results are pretty solid. Like I can repeat that the final results are pretty solid. There is a happy end, by the way, to this whole frustration. It was really frustrating exercise. Okay, so the high level idea was simple. I have so QuickSort. The idea is really simple. I have a range and I want to sort it. And each iteration, I'm going to pick a value and have shuffle the values of this range, of my specific range. Everything that below and equal would be on the left-hand side, and then the bigger numbers would be on the upper hand side. Just like we learned in school, there is this pivot that we pick. What pivot we pick and all, we'll talk about it in a second. But the idea is that each iteration for each specific range, you find the location, the right location of the pivot, as if the whole array was sorted. Basically, in other words, we're actually talking about the nth element. Okay, so the nth element basically is something that we as C++ community, we already have this as part of algorithms header. You can actually take a range. So a range would be a first, last, and the nth. You say, okay, I want you to give me the to arrange this as if the 7th was here. So basically, here's the explanation. Nth element is a partial sorting algorithm. So it's not sorting the whole thing, but it takes first and last, such that the element pointed by the nth is changed, whatever element occur in the position were sorted. All of the elements before the new are less than or equal, and elements after the new nth would be bigger. Very simple idea. So let's say we pick the last one always. When we have a range, doesn't matter if the whole array or just a slice of it. The idea is that we pick, at least in this exercise, we pick the last one as to be the pivot. You can always pick any of these, put it at the edge, shuffle it, kind of swap it, put it in the end, and the algorithm would work as if it was picked from the end. But it doesn't really matter. Let's say that the pivot is also, it's always the last one. So let's say we have 3. So that after the first iteration, we'll have 3 here, and then everything that below and equal 3 would be here on this side, and then everything above. By the way, there is a tab. This is something not for me. I just copy it from some website in the internet, but this is the typo. This needs to be greater than. Everything that's greater than 3 would be on the left, on the right hand side, and then continue slice and dice. So basically, we have a log n operations, and we are done. So it's a very simple, but I'll explain that in more details. So the actual implementation look like this, and this is a screen capture from Geeks for Geeks. It says C++ 14, but it's basically a C. They have their own swap implementation that swap two values. There is the actual QuickSort function that would be invoked recursively every time. So there are two operations. One is partitioning, which basically takes the pivot and would find the location of the pivot while shuffling everything that is below or equal to the pivot to one side. Everything that above would be on the right hand side, and then the pivot would be there. That is what partition is returning. And then we'll do QuickSort on the 2 halves. And this is how we continue, and this is how we finishing the sorting. This is what QuickSort is doing. So I just in case you still kind of trying to remember how it works, let's say that we have this process, okay, and we are in the middle of so not in the middle, but let's think about a partition process that we have the pivot as 5, and we started everything, all the pointers were started here, and 2 is less than 4, 2 is less than 5, 4 is less than 5, 1 is less than 5, and we continue and we until we hit something that is less than, again, less or equal than 5. In this case, what we need to do is the following. This smaller so far is basically I'm advancing that, and then this 8 pointer goes here. Okay. Again, so the smaller one was, the smaller pointer was here. This is where we track what was the smaller so far, and eventually at the end of the process, this pointer would tell us where we should put the pivot. We swap the pivot at the end. So basically, I'll show you the code again, but there is another one that just traverses all the way here. And every time I hit something that is less than a pivot, I'm going to put it here. So you can see that 8 was swapped with 0. And now 0 is what we point is 0 is the next one, and then I'm advance the next one. At the end, I'm gonna have this one. So this is the smaller so far. This is the next to it. So we traverse the whole thing, and the only thing that left us to do is put the pivot in the right location. What we do is we swap at the end. We swap 5 and 7, and we end with this specific state where everything here is less or equal than 5, and everything here is bigger than 5. If you look at the code here, this is exactly what is being done. So the pivot is some value that is the last one from the array, and then we have an index that would give us the lowest one, and there is all kinds of very funky low -1. And I wanted to, this whole thing that I wanted to modernize. I didn't want a row loop. I wanted something much more kind of modernized, because it's really confusing. Low starts with 0, and then you have 0 -1. You actually start with -1, and it's confusing, but it is true, because what happened is that they're doing +1 if you don't have anything to advance this index. So it works, but it's confusing. You always need to know, is it +1, -1? But the idea is the following. You have the index, this index, that would only move when you find something that is less or equal to the pivot. This is the only time it moves. And if you have another index that just traverse the array, so this index would be j, just traverse the array, and then if we find something, then we swap it. And the last thing that we need to do is actually put the pivot, we swap it with the next one, so 7 would be instead of 5, and then we calling QuickSort each of them. So hopefully, and this is what happens here, you can see that this is the partitioning point, and then we do QuickSort of the array from low to the partitioning point -1, because we don't need to touch the partitioning point, and then partition point +1 to the highest, and then recursively call it. This is basically it. So the road to modernize the whole thing, again, very frustrating one. So I started with a very naive approach, a very small array. I already gonna upfront tell you that I tried all kinds of things, having a heap allocated, which is stud vector, or maybe stud array just on the stack. And I used quick bench to benchmark the whole thing. But I started in a very naive approach, having just an array and just call QuickSort and see what happens. Now, the reason I'm doing stud prev of stud end v is because if you remember, QuickSort wants to have the first and the last, not because stud end is the one past the last. Always remember that the abstraction of standard iterers is the stud end. The end is always pointing to the element past the last one. You cannot dereference this element, by the way. It's undefined behavior, but there is something there that signal this is the end. So I needed to preserve the semantic. I needed to have from the first element to the last element. So this is the prev of stud end. So a very naive approach would say, look, I have, first of all, when am I done? I'm done where low is either equal or bigger than high. So think about there is a low and high, and we start slicing this array, and eventually low and high would be the same, and I'm done. So it's only one element, so I'm done here. So that's one thing. And the next one would be partitioning between low and high, and then QuickSort between low prev of p versus next p, because it's p +1. Again, I wanted to modernize it to high. So this is the QuickSort. But what about the partitioning side? So the partitioning side, if you think about it, I wanted, again, this was like the first thing that I was writing. So everything is iterator here. I'm returning iterator. I'm dealing with just iterators. So the pivot is high, and the iterator starts with low. I'm going to iterate over that. And lowest is the other index that keeps the lowest value. And eventually I'm swapping the lowest with pivot. So this is lowest of, remember, lowest is the index that keeps record of what is the lowest one. Then we swap the pivot. And what I was thinking is, what actually I need to do for each iteration. I need to find the next one where the value that I'm looking at is either less or less equal than the pivot. And if I'm actually done, I'm done when I'm actually hitting the pivot, so I can break. I don't need to do anything. But otherwise, I need to swap the elements. Okay, so I'm doing find if. I'm getting an iterator. If I found something, so basically find if would give me the next one. I'm swapping and then continuing doing find if. Basically, that's what I need to do. But when I put it on Clang or GCC, it was kind of horrible experience. So this is Clang 11, I can see. It was 1.8 to 2x. I remember GCC had the same kind of ratio between these two. So I said, okay, that's fine, no panic. Though I kind of was disappointed that there is, because I was using Lambda, I was using find if, but I was hoping that this high level abstraction, because we're always trying to use high level abstraction instead of using index, so the idea is, the semantic is, look, I want to find the next item that is less or equal than pivot. So find if is really, so it's not mutable lambda. Everything is fitting very well to what I'm trying to express here, but it doesn't work. This is C++20, Clang with libstd C++. We'll talk about this dimension later on, and O3, we'll talk about this dimension also. But I didn't touch the C++20, so I used C++20, and back then it was 11. I think today there is 12 in QuickBench. So I said, okay, I started with 10 elements, basically 10-ish elements, and I said, okay, let's see what happens if I have more elements. So I said, okay, let's have 150 elements. Just decided to have 150, no particular reason. So the next thing that I was thinking about is, okay, forget about dealing with iterators. How about I'll deal with span? And again, I mentioned that before. I tried to see if stud vector or stud array had differences. It's the same. There was no difference between heap allocated or array, which is good. I didn't want to have anything related to this. So the QuickSort has this implementation that would be recursively being invoked, and it's pretty simple. And the span is basically a view. And I really like the span versus the iterator one because it's less writing. If you can see it, it's less convoluted. So initially I have span of the entire vector. If the size is either equal to 1 or 0, I'm done, because the slice that I want to sort is just 1 or less. I call partition. I'll get P, and then span has a lot of very, very good functions to get slice out of this and other slice. I'm using kind of Rust terminology, sorry about it, but span is basically kind of a slice. So for the first P, so I'm getting a slice out of span, and then the last p minus 1. So the size minus p minus 1 would give me the last elements that I want to recursively. So if you think about, if you have size of 4 and p would be 1, so we need the last 2 to sort. So it will be 4 minus 1 minus 1, which would be 2. Now the partitioning is pretty simple. I have that back that would give me a reference to the pivot. I have an integer that would point to the lowest element, and I'm using an index here. Not ideal, and we'll see how this would change the whole thing when I stop doing that. But it's a range for loop, still more than C++. It's not lambda, but it's fine. If the element is less than a pivot, I do a swap. I increase the lowest because the lowest is keeping track of what is the lowest one. At the end, I'm just swapping the pivot with the lowest, and I'm done. So let's take a look what happened here. So I'm getting closer. This is much better. Clang is great. GCC is awful. By the way, GCC was the most frustrating part of this exercise. In this case, both of them had 10-ish elements. I moved to something else, to like 150. But we're already seeing like kind of that we are in the right direction, at least on Clang. GCC is kind of, I don't know what's happening there. But it's already thought that, okay, lambda and find if is not the right thing. Range for loop with span looks much more promising. Okay, what if we have more data? So when we got more data, actually Clang was doing a bit worse, 1.2x. So from a moment that it was actually doing a bit better, kind of marginally better, it is doing now worse. The C style code, by the way, kind of didn't mention that, so I'll mention that in this slide, was always faster. Okay, so until now it was always faster. Same longer length array. So here it was kind of beating, but once I started with the longer array, no matter how many times I tried to run the benchmark, the C style was doing better. Now, I didn't mention it yet. Obviously, there's a lot of work to be done, but I was looking at the generated code, and now I'm actually moved to 150 elements, so bigger elements. The code generation was shorter on GCC, but on both on C++ and the C++, both on the C and C++ versions, GCC had this generated code. Doesn't matter if it's a small or big arrays. With small arrays was 10-ish. Clang always had smaller code generated compared to GCC. So GCC had this very large code, and I think what it was doing, maybe doing kind of a loop unrolling. But once I moved to 150, the code shrinked from a very long generated code to a smaller code. Clang was very consistent always. There was no long code generation no matter what. So GCC was kind of doing a lot of kind of clever, trying to do like kind of clever loop unrolling. So 150 elements remove this whole long generated assembly code, and I have a smaller generated code. So this is something that I noticed moving to 150 elements. Then I tried to do all kinds of things to see if it would make things better. For example, I realized that there is always a redundant compare that we do in the C and in the C++ implementation. We compare the pivot to itself. So if you think about it, eventually the element would be the pivot. And it's maybe redundant. I didn't know. So what I did is I created another span without the pivot. I know it's actually not more work, but I said maybe there is some optimization, and I said, okay, I'm gonna save one. This is the really micro optimization right now in my micro benchmarking. I'm gonna save one and see what happens. It didn't really make a huge dent. I could see that it's a bit better. I kind of reran and cleared the cache and reran it, so it's a bit better, but nothing really substantial that I would like. This is definitely not the right direction. Like one element out of 150 elements didn't really do anything useful. So what about using libs to C++? So I remember I told you that there was this option. There is an option in Clang. Clang can work on two different can compile and link against two different libraries, two different STL libraries. One is the libs to C++, which is shipped with GNU compiler, and the other one is the libc from Clang. So things like swap would be different, span would be different. And what I saw with long arrays, O3, I removed the single pivot, but it doesn't matter. I just left the code as is and just try to see what happens if I just have a libc++ implementation. And I actually realized that libc++ is doing much better. It was very, very consistent. But I didn't pursue that. I actually revert back to use libs to C++ because I wanted to have kind of an apples to apples, because both of them, both Clang and GCC, I wanted to work on the same implementation of span and swap and whatever else I'm using. Basically, span and swap was the two standard library elements that I'm using. So I wanted to stay with the same one. Obviously, GCC doesn't have an option to move to libc++. So the common denominator was just using libs to C++. So I reverted that. But that was actually encouraging. This is very kind of consistent that lib C++ is better. I don't know what span is implemented is better or swap, but eventually it gives me a better code. Okay. So the hunt continues. And I say, okay, what about having O2? So long arrays O2, going back to libs to C++, and I saw that Clang is doing better. Now I didn't investigate more what happens to the assembly code, something that definitely needs some work. But GCC actually with O2 went south. That it just didn't, like O2 definitely, OS and all of that stuff just didn't work well. O3 was definitely the closest one on the same one. So again, long arrays, pivot compare. And then I said, okay, well, how about sprinkling const or more const in, like, would it make a difference? And it didn't actually make a difference. Actually make things, I think, a bit worse. But both of them showed, I don't know why const would show slow. I need to go and figure out if there is maybe some of the moves are disabled. I didn't investigate it more. It's something that I need to go back and investigate. But sprinkling more const didn't do the right thing to make things better. I told you there is a happy end to this whole thing, and you can see the icon of Jason Turner. And so I reached out to Jason and said, look, there is this thing that I'm trying, just playing with something, just to see if I can take something and modernize it and prove that it can be written without indices, without and actually learn and apply it to other things, just by looking at the results and conclusions. And he tried it out for probably some time, for a few days, and came back. And he came back with so I marked the the things that he changed. And this actually made the difference. It's marginal, but it's very stable. It's very solid. I didn't try it with later compilers, but it's very solid that this is actually make things better. Now, I don't know why I didn't think about using iterators instead of indices. So if you remember, this was an integer, and I was indexing into V. Okay, and the idea here is don't use the index, just use an iterator. So it's V begin to track the lowest, and there is a dereference here. In my opinion, it should be the same, but it wasn't the same. The additional thing that you need to keep in mind is that the place, so we need the first X elements, and X is an integer. So we need to compute the integer. So there is actually a very simple, it's actually the code generated here from this to distance. It should be from begin. It's basically pointer arithmetic. That's it. And we get the place because we get the number, and we can say, okay, V dot first place, and then V dot last size minus place minus 1. Place is just an integer now. And this actually did the trick. Now, when I went back and checked the disassembly code of at least Clang, I also checked the one from GCC. It was very, 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 very close to each other between the C. This is the left-hand side. You can see that from the naming to the right-hand side, which is using span and all. So if you look at the instructions, they are very, very close. There's like from this compare to the jump greater equal, it's very comparable. Now I'm talking about the instructions. The time that it's spent on the compare here is much bigger from here, but just ignore this one. Just look at the generated code. There is a move compare set E here, move compare set E. So we ended up with a very, at least generated code. It's very, very close. We actually kind of surprisingly a bit better in terms of the runtime. It might be marginally, your mileage may vary, but the bottom line here is that we can definitely, this is the happy, by the way, you can look at my GitHub. There is everything is there. The README has all the information, but we ended up with a more modernized, using span, using iterators, using range for loop. There is no index here. There is this funky thing here. True. Didn't avoid that, but we definitely can think about something else here. But anyway, this is, in my opinion, kind of much better and more modernized than the other approach. The other approach, by the way, what I didn't like from the first moment I looked at it, and I want to show you this. I didn't like this low -1, like your index. Like I needed to run this and say, okay, what happened if the index is not advanced here? So you're actually looking at the first array, and you take your pivot basically is the smallest one. So you do always I+1 and put your pivot into this I+1. But I didn't like all this I+1 and I-1, and so there's I-1 here, there's I+1, I+1, and I didn't want to have that. I wanted to have something just maybe easier to read. Hopefully it is easier to read for others. Also, the span is, I think, much better than having an array low and high, because the span is a slice internally that has functionality to deal with the slice. So I definitely think that the end result, obviously people can disagree, this is fine, but I definitely think that the result is much more nicer. It's nicer here. So that's it. That's it for today. Thank you for sticking around. If you have any questions, Any comments?
Hey, thank you, Kobe. I joined late, so and this is my first meetup, so I'm not sure what the proper etiquette is on asking, right? So sorry, but
You can ask anything.
okay. So
I'm not promising to know
there
everything.
is an STD, like you said, modernize, right? And STD sort is there.
Yes.
So
Oh,
did you compare
yes.
that?
Yeah. Thank you for. I completely forgot that. Obviously, there is sort that is probably doing a lot of clever stuff. I didn't compare that. This is something that was kind of outside of the scope. So what I wanted to do is basically take an existing, very simple QuickSort algorithm that someone wrote that outside of the standard and try to modernize it and say, it's just an example. Take this exercise and kind of extrapolate it to anything that is written in C and say, okay, can I modernize it without the penalty to using C++?
Sure.
And,
Yeah.
And yeah, but I didn't try it because it was kind of outside. Like I knew
it was outside the scope of your mission, but yeah. But I mean, it would be interesting just to see, like that. Yeah.
I had a feeling, by the way, I completely forgot to mention that. So thank you for mentioning it. I had the feeling that sort would beat both of them, but it's a good. I'll do it. I'm actually gonna do it either today or tomorrow because it is something that was on my plate and I've completely forgotten doing it. It's really interesting to see what would happen.
Right. And you made a comment on the one slide that you tried a bunch of const references and it didn't work, but I thought some of, modernization was like const expression, right? So you do it at the template time and not at the compile time. Like did const expression, was that one of your experiments?
I didn't see any opportunity for constexpr here, but if someone has any idea, again, this is, I can definitely would like to take that to Discord and have, there are a lot of smart people that are on the call. I want your opinion and the idea. Okay, so here's the bottom line. I'm a C++ engineer, which means I use C++ and I want to advocate for C++ because I think it's safer than the other options. And I want to. There was a discussion on Twitter this week, by the way, from Vittorio and others, about when we write C++, do we want to write for maximum optimization or do we want to have abstraction? There is this slide where you might go into more abstraction and you lose performance, or you go into more performance and you lose abstraction. So the question is, where is the sweet spot? And there is a disagreement from many people. What does it mean writing C++ in efficient and in abstract? Like, what is the sweet spot of writing that? And what I wanted to do is to check the limit, and I actually learned a lot of things. For example, I learned that like what Jason Turner came back and said, okay, don't use this integer as an index, use an iterate. I would never think that this would actually make a difference. And he actually tried that. Look, here, Kobe, I tried it out and I don't know. He said, I don't even know why it's working better, but it's definitely working better. And I took it and it was very solid that it's working better. I don't know. And this requires looking more deeply into the generated code and see what happens and why. It takes more time that I didn't spend. But the bottom line is that I wanted to prove, at least in this exercise, that this is possible to some extent. Obviously, it's not.
It's a learning exercise as much as an optimization exercise, right?
Yeah, it's learning. It's definitely learning how to use span. And if you already use span, I learned that I should stick in the same domain, use the iterator that I get from span, but not using an index and index into something, like moving away from the domain of the iterators that span gave me. That's one thing that I learned. Again, is it true for anything out there? I don't know. You need to measure anyway. And this was really a really micro benchmark. By the way, there is a book that maybe I'll mention that, probably mention that next time. I have it actually here. I'm gonna stop the blaring because I want you all to see it. I don't have it ready. 1 second. Let's see. I'm gonna change the blurring. Oh, okay. So this one. So there is a guy named Fedor. He's in the committee, and he wrote this book. I think came out like last month, and I started reading about it, and it's all about micro benchmarking. Not all. I'm just a couple first chapters, but it's very interesting. Like he changed in micro benchmark. He changed an integer of from signed to unsigned of a loop, and things change. Like from an unsigned, it changed to an integer when he doing a for loop, and things are better. And he explained, okay, I'll explain in the next chapter why. And so this is probably a kind of an unsigned has this wraparound, and an integer is something else that like it's undefined behavior to wrap around. There's no wraparound basically. So there's all kinds of stuff that I think are different between unsigned and integer. So there are lots of stuff. I always suggest that the whole curiosity drove me into this exercise, always suggesting people to go and measure their code. Don't go into like crazy assumptions right in the beginning of when you write your code. But I would say if you have access to span, either std span in 20 or you have span light, you can take because there is span light and there are span implementation out there in GitHub. And if it's something that your company can allow you to use, I would say reach out to span in order to use it for a view, for a slide, just like string view that we have in C++ 17 instead of indexing. So that's one thing that I obviously would remember when I need to deal with slices. Okay.
Thanks. Sorry, I feel like I'm talking all the questions, but what was the comparison tool? Like the thing that showed, sort geeks and sort. What was that tool?
QuickBench.
QuickBench. Okay, thanks.
QuickBench. It's an online, and you can if you're familiar with Godbolt, there is a button that takes your code from Godbolt directly to QuickBench and vice versa. There is a button to go back to Godbolt. So QuickBench.
Hi, Kobe. This is Wei. Thank you so much for your course for me. I just I looked at your GitHub page of QuickSort, and there are so many links. Do you have a table that compares all the results?
Yeah, I'll put. Yeah, I need to compile it into a table. I'll do that. Yeah, I know. I know the README has all the links of all the steps that I had, but I'll compile it into a table.
Yeah, and I'm not the expert of C++, but I saw you compile. Sometimes compile with the GCC. Sometimes you do with Clang. Do you think there are big difference when using these two?
I saw differences. This is again, it's a micro benchmark. I don't know what happened. I never had an opportunity to take a big software, compile it on GCC, compile it in Clang, and compare these two. I always compare GCC and Clang on a very small subset of code. So, and I saw differences, yes, but when we always see differences in code generation, they don't generate the same code. You can even tell Clang to use a different standard library, and things would be different because the standard library is different. It's a different implementation, different people want different stuff. So I don't have experience of trying something very like a large scale software and compile it here and there and try it out in many scenarios. It's always small benchmark of a specific code. And this is, I'm doing it only if I want to see differences. Usually at work, if I have a specific compiler and I want to benchmark it, and I'll use Google Benchmark, again, doing as much as I can to provide a nice environment that mimic the real thing. It's hard to do. And I'm going to stick with the compiler that I'm using. I'm not going to have something more than that because if I'm using GCC, I'm using GCC. That's it.
Yes. And I do see you compare with O2 and O3. Can you give me a take home message?
Yeah, so playing with the optimization flags sometimes surprisingly it gives you other things. There is also OS that give you a smaller binary. Sometimes the binary will be bigger because there is a loop unrolling and things like that, and if you want a smaller one, but so there is all kinds of. I'm going back to the
because I don't know the difference. I think O3 is more aggressive, but I really don't know the difference between O2 and O3.
So the spec each. So there is O1, 2. There is OS. There is O for the size. And there is also O fast that I didn't try, and I don't remember from the top of my head. But if you go to the documentation of the compiler, you can definitely see what dash options, compile options is enabled in each of them, but I just can't remember.
Yeah, because I look for speed, so I always try to be aggressive. So I always use O3, but I don't know whether that's the best practice or not.
I always use O3 unless I prove myself otherwise. One of the things, kind of a side note, that I was seeing in a lot of software is that people were using stuff that would be undefined behavior, that would cause undefined behavior, and O3 would actually render a buggy code. So they would fall back to O2, but that's not okay. Okay, so don't do that. Don't write an undefined, like they were like writing an undefined behavior consciously. That's even worse. And saying, okay, we can't do O3 because with O3, the compiler would exploit what we're actually doing. So they would stick to O2. I think it's bad. Don't do it. Don't do it at home. So yeah, stick to O3, write code that is defined, and
I don't remember if it's still true or not, but in the past, O3 was considered a bit unstable.
Yeah, I don't remember.
Could generate bad code. So
yeah, I don't know if it's unstable. I think we definitely default to O3 in many cases, especially with CMake when you do CMake build type as release in the GCC and the Clang one that CMake would default into O3, and you can see it in either in your Ninja output or your GNU Make output. You can see that it's O3, so it's defaulting. But I remember it was kind of risky sometimes to have O3. I remember it like a long time ago, but hopefully it's not. Hopefully it's good. But we had a lot of discussions internally in Qualcomm when we discovered all kinds of weird behaviors. We took Jehan knows about it. We took a snippet of code and played with it, and we saw all kinds of strange behaviors. So there is no bottom to hold this whole thing. Yeah, Martin.
Yeah, regarding the optimized QuickSort code you wrote and using index versus iterator, what comes to mind for me is that if you have a base address plus an index that varies, right, that still needs to be computed. the final memory location needs to be computed. Whereas iterators, oftentimes especially in release optimized code, they themselves are implemented using just raw pointers.
Yeah.
So they already do point at something. There's no need to do pointer arithmetic. And I wonder if that is
it might be.
That is what you saw.
Yeah. Yeah, it might be. Again, this is a good point. This can explain why we see this gain just by not using index, which is basically our pointer arithmetic from the base plus. So
we recently actually ran into a bug at work with MSVC, with Microsoft's STL, because despite compiling in the release mode, they were still using debug code path in some of the iterators. So anyway, but this was a clear way to illustrate that depending on how you're optimizing pointers, pointers are used in place of iterators because they're syntactically they're identical, right?
Yeah. Okay. Okay, thanks. It was very great seeing all of you again. See you next time. Happy Thanksgiving, by the way. Happy Thanksgiving next week. Happy Thanksgiving. Have a good rest of your week, rest of your day. Stay safe. Happy to see all of you. Thanks. Thanks. Bye-bye.
Thank you. Thank you.
Thank you, Kobe. Goodbye.
Thank you.